Today we're going to be looking at geometric movements, and a geometric movement is just looking at any way that a shape can be manipulated, changed, or just like it says in the name, the way that it can be moved. So in this case, we're looking at how a shape can be moved either across a vertical axis or a horizontal axis. And a vertical axis would be like if I'm talking about a graph, our y-axis, the fly. Up and down. So in this case, the shape would be moved from left to right. Oh, excuse me. So it's moved from left to right. Now, if I have the horizontal axis, I'm talking about taking my shape and moving it up or down. So in this case, it would be moved across the horizontal axis, which is also like the x-axis. It's the walk before you fly. So the y is the fly, and the horizontal is the walking axis. You can think about it like the horizon. If I look out onto the horizon, I can see where the sun sets, where the land extends to, etc. So the first geometric movement that I'm going to look at is a translation. And if you remember from last year, we know that all of these geometric movements have tricks in their names that tell us what to do. So hopefully when you saw translation, you immediately saw that SL and you recognize that this is a sliding motion. So I'm going to start with my original figure, and I can slide this ballerina to wherever I would like her to go, whether it's up, down, on the diagonal, does not matter as long as she still looks exactly the same. So imagine that I put my finger on this ballerina and I just push her to a new location. That's essentially what I'm doing when I'm sliding. I'm not turning her, I'm not flipping her over. All I'm doing is pushing her to a new location, sliding her. So she's kind of dancing across my stage in all different directions. So that would be my translation, a slide. Now the next movement is a rotation, which has a T, and that tells us that I'm going to take my current shape and I'm going to turn the shape. So if I have my ballerina, she starts off like this. If I want to take her and turn her, I am actually going to turn her to the side, or I can turn her down. And this direction can move clockwise or counterclockwise. So if I decided that I didn't want her turning to the right, then I could turn her to the left in a clockwise direction. So on these two, I turned her clockwise. Maybe on this one, I turn her counterclockwise. Anytime I'm talking about a turn, I'm referring to it in a matter of degrees or as a fraction. And if you can imagine that my ballerina here is standing on a circle, this is the easiest way for me to know how many degrees she turned. And we usually think of a circle divided into fourths. So if my ballerina is standing on this circle and she turns towards this position to the right, she has essentially covered 1/4 of the circle. So she can turn all the way around until she's standing back in the position she was, which would be 4/4 or one whole turn. Or she can just turn fractions of a turn. So in this case, if my circle's divided up into 4 pieces, she turned 1/4 of a turn. And if I know anything about this picture in fourths, I can see that I have perpendicular lines. I've got a 90-degree angle. So she turned a 90-degree angle, or 1/4 of the circle. Now, my ballerina who's facing down below, she turned half of the circle. So she made a 2/4 turn. So she turned past the 1/4 to the 2/4, which we could simplify to say a 1/2 turn. And now she has two 90-degree angles. So 2 times 90 degrees would equal 180. Excuse my handwriting. It's hard with this mouse. Now, in this case, if she turned counterclockwise, she still only turned 1/4 of the circle. She just changed directions. So she was still turned 1/4 or 90 degrees, but this time it was in a counterclockwise direction. Had I counted her going clockwise, then she would have made a 3/4 or 270 degree turn because she did 3 90-degree segments. So 90, 90, and 90. 9 times 3 is 27. So it would be a total of 270 degrees. So the last one that we are going to look at is the reflection. And in the reflection name, of course, we have another trick that tells us what to do, and it is an FL, which stands for flip. So I'm going to take my ballerina and I'm going to make her flip. So if she starts out in this position, I can make her flip across a horizontal or a vertical axis like we talked about at the beginning of this video. So here would be my vertical. It's my up and down, it's my fly y-axis, or I can have her flip over this horizontal x-axis over here to the side. So a flip is essentially like if you've ever taken some paint, or if you fold a piece of paper in half to cut out a heart, and if I fold it in half, it makes a mirror image on the other side. It makes it symmetrical if I were to cut it straight down the center. So basically I am going to have the same shape on both sides of a piece of paper, and I want it to be symmetrical. So if I fold the paper over, they would match up perfectly. So in this case, if I just move her over here, that's a slide. If I take this, and this is a piece of paper, and I fold it down this crease, this ballerina is not going to match up with this ballerina over here. So I need to take her and flip her in order to make it symmetrical. So see how if I line them up right here, there's a line of symmetry. So a flip is essentially creating a line of symmetry. In this case, it's that vertical line of symmetry that's going to serve as how we flipped the ballerina. But I don't have to have a vertical line of symmetry. I could have a horizontal line of symmetry. So if she starts off like this, I'm going to move my axis up so I don't mess up my recording. If I want to flip her down now I'm kind of taking my paper, I'm making the hamburger fold, and I want whatever is up here to fold down and match up down here. So now if I cut the paper on this side, they should be symmetrical. So I take my ballerina. She's not symmetrical because if I take this end and I fold it down, if I fold it straight down, they're not going to line up. So instead, I need to make sure that she's like a reflection. It's like she's standing by the side of the pond seeing her reflection, or looking in the mirror. There's got to be that line of symmetry, in which case that's our horizontal axis. And I'm going to take her, and you can see that an option on my computer is to flip her left and right across the vertical axis, or up and down across the horizontal. And now, if I line them up toe to toe and I cut it in half, it's symmetrical down that middle point. So now I've made a reflection across the horizontal axis that shows that she has flipped. So we've got 3 total geometric movements: our reflection or our flip, our rotation or our turn, and our translation or a slide.